Hey mathematicians, so in this example, as opposed to the previous one, you can graph this one by intercepts pretty easily. And the reason that you can is because 12 divided by 3 turns out to be a whole number, and 12 divided by 6 also turns out to be a whole number. So it makes it really easy to graph by intercepts that way. So think about what an intercept actually means. So an x-intercept means that the line is going to hit somewhere here along the x-axis, which means that the y-coordinate has to be a 0, because any number that falls on the x-axis has to have a y-coordinate of 0 for it to be there in the middle of the graph. So again, in order to find the x-intercept, the y-coordinate has to be a 0. So I'm going to use that. And I'm going to put a 0 in for y. And of course, anything times 0 is just going to be 0, right? So that's really going to cancel out. Right here is going to be gone because 6 times 0 is just going to be 0, which leaves you with 3x is equal to 12. Divide both sides by 3. So your x-intercept is going to be a 4. So the y-coordinate is a 0 and the x-coordinate is a 4. So the shortcut for finding the x-intercept is just to take the constant and divide it by whatever number is sitting there next to the x. And by using the opposite logic, the y-intercept, sorry, my handwriting is really killing me today. The y-intercept, in order for something to hit the y-axis, the x has to be a 0 because it would be in the middle of the x-axis. So I'm going to rewrite that same equation, and instead of putting a 0 in for y like I did the last one, I'm going to put a 0 in for x. So the same idea is going to happen because anything times 0 is still 0. So the 3 times 0 is really just going to cancel itself out. So that then you're left with 6y is equal to 12. Divide both sides by 6. Your y-intercept is 2. So the shortcut to find the y-intercept is to take this constant and divide it by the coefficient, the number that's in front of the y. So now that we've got our two intercepts and they're at exact integer locations, we can just add our line. Make sure you stretch it out all the way across the graph. And make sure you add arrows to it so that it is still mathematically correct. So in this one's case, you can very easily just divide. Again, the shortcut is dividing that constant by each of the coefficients. Remember, coefficient is the big kid word for the number in front of those variables. And then I always think it's a good idea to verify using Desmos. And sure enough, if I type that equation into the Desmos calculator, there's my x-intercept at 4. And there is the y-intercept that I calculated at 2. So I've got a pretty good idea that I probably did it correctly.